Hello friends, in today's class we will see data center virtualization for cloud computing, and this topic will come under technologies for network based system in grid and cloud computing. First, let us see the data center. Data center is designed based on network, but in this network it contains huge computing and storage devices. The computing devices are basically the HPC systems, that is high performance computing devices, and the huge sized storage devices also connected together to form the data center. Basically the size of data center is very big in size. The data centers are enabled to handle and delivery of shared applications and data. The next one is modern data centers. The data centers shifted to virtual networks are called as modern data centers. And this data center supports application and workloads across pool of physical infrastructure and into multi-cloud environment. That means the applications and workloads will be shared between the cloud environment are called as modern data center. What is meant by multi-cloud environment? So it is connected across multiple data centers, the edge, public and private cloud. That is, more number of clouds will be connected together to form the multi-cloud environment. And the public cloud is a collection of data center. More number of data centers will be combined together to form the public cloud. When applications are hosted in the cloud, that is, if any user hosts their application into this cloud, means they are using the data center resources from the cloud provider. So here they are having data center. This is maintained by cloud provider. That means the user is going to access the resources of data center from the cloud provider. The next one is associated components in the data center. A data center which contains routers, switches, firewalls, storage systems, servers and application delivery controllers. So these are the components are very important to design a data center, because these components store and manage the business critical data and applications. So to manage the data and applications, these components are very important. Apart from this, the data center security is very important here, and that is very critical in designing the data center. And the data center provide network infrastructure, storage infrastructure and computing resources. Network infrastructure, which is otherwise called as network servers. Storage infrastructure is otherwise called as data server, and computing infrastructure is otherwise called as application server. Okay. And network infrastructure, and this connect the servers, data center services, storage and external connectivity to the end user. So it will connect all the internal data center components to the end user. That is called as network infrastructure, otherwise called as network servers. And next one is storage infrastructure. The storage systems are used to hold the user data. User data is actually very huge in size, and those huge volumed data will be stored in this data servers. And the another most important one is computing resources, and this is otherwise called as application server. These servers provide the processing, memory, local storage and network connectivity that derive the applications. Data center virtualization for cloud computing. So to construct the cloud platform, popular x86 processors will be used, and low cost terabyte disk and gigabit ethernet are used to build data centers. And the data center design emphasizes the performance per price ratio over a speed of performance alone, that is speed performance alone. And worldwide about 43 million servers are used in the year 2010. And the cost of utilities actually exceeds the cost of hardware after every 3 years. That is, for every 3 years the cost of utilities exceeds the cost of hardware. And the most important one is managing and maintaining data centers. For that is, managing and maintaining data centers are very difficult for small and medium business people, because they need to invest more amount to construct and as well as maintaining the data center. This is very difficult for these people, hence they will go for virtual data center from the service provider. The next one is virtual infrastructure, that is growth and cost breakdown for data center over the years. And in the x-axis indicates the year, and this y-axis, left hand side y-axis indicates cost in dollar, that is the customer spending cost in billion dollars, and this right hand side y-axis indicates million number of servers installed, and this one green color indicates the power and cooling expenses in a data center, and this orange color indicates management cost, this orange color, and the blue color indicates server spending, that is amount spending for server, this blue color. And we can see this one is virtualization management gap. This peach color indicates virtualization management gap, that is no need to install the amount need to spend amount for management and power and cooling expenses. So in this diagram we can see we need to spend more amount for management cost when compared to hardware cost. Management cost got increased every 3 years when compared to the hardware cost. In a large data center, there are thousands of servers will be there, and small data center typically built with hundreds of servers. In this data center, 30% of data center cost goes for purchasing IT equipment. That is, we are spending only 30% amount for spending the IT equipments. The balance 33% is going for chiller, that is cooling system, and 18% for UPS, and 9% amount for air conditioning, and the 7% amount for power distribution, lighting and transformer cost. And hence totally 70% of cost to run the data center is allocated to management and maintenance. So for managing and maintaining we need to spend 60% of total amount. The cost of electricity and cooling did increase 5% to 14% in 15 years. How to reduce the cost of data center, that is low cost design philosophy. Normally, the high-end switches and routers are too expensive to build the data centers. Hence, using high bandwidth network may not fit to economic of cloud computing. Given a fixed budget, commodity switches and networks are more desirable in data centers. That is, somewhat low cost switches and network may be enough for constructing the data centers. Similarly, using commodity x86 servers is more desired over expensive mainframes. And the software layer handles network traffic balancing, fault tolerance, and expandability. Currently, near all cloud computing data center use Ethernet as their fundamental networking technology. The next one is convergence of technologies. In the convergence of technologies, there are four areas. First one is hardware virtualization and multi-core chips. And second one is utility and grid computing. And third one is SOA, Web 2.0 and web services. And the last one is autonomic computing and data center automation. Let us see all these things one by one. The first one is hardware virtualization and multi-core chips, and these are very important to enable the existence of dynamic configurations in the cloud computing. And the next one is utility and grid computing technologies, and that will lay the necessary foundation of computing clouds. And the next one is advancements in SOA and Web 2.0, and those technology will push the cloud computing into another step forward. And finally, the achievement of autonomic computing and automated data center, those operations will contribute to the cloud to raise of another level. The next one is data in data center. That is, how do we get data in the data center? Data comes from sensors, lab experiments, simulations, and the web in all scale and formats. Preservation and movement, that is preservating data and movement of data and accessing massive data, which requires generic tools. Some advanced tools are required to support high performance scalable file systems, databases, algorithms, workflows, and visualization of data. In January 11, 2007, the Computer Science and Telecommunication Board, that is CSTB, recommended fostering tools for data capture, data creation, and data analysis. A cycle of interaction exists among four technical areas. First, the cloud technology is driven to handle huge volume of data, and cloud computing explores multi-core parallel computing technologies and data intensive computing, which needs to address workflows, databases, algorithms, and virtualization issues. Next one is virtual data center. Virtual data center is a pool of resources. Resources are processor, memory, storage, that is spaces, and networking bandwidth, and those are designed for enterprise business needs. And these virtual data centers are the virtual representation of physical data center, complete with servers, storage clusters, and lot of networking components. And all these components are in virtual space, and those are hosted by one or more actual data centers. The end users and the small and medium scale business people are also not ready to invest that much amount for constructing the data center, and also the management and maintaining cost of data center also very high. Hence, these people will go for virtual data centers. And in the next class, we will see another important topic in grid and cloud computing. Thank you.